Welcome to Ask and Learn.
All right, this question here is all about power and how it relates to the conservation of energy. So power's definition is change in energy over time, and it's measured in watts. So we have that equation right here, change in energy, final minus initial energy, divided by the time in seconds. Now the energy has to be in the standard units as well, and that's in joules. So for that to occur, I need my velocities in meters per second. So up here, very first step, when I start listing out what do I know in the problem, I've got my mass, 1,080 kilograms. That's in the standard unit necessary. But the velocities are not, they're in kilometers per hour. So I need to convert those by taking 1,000 divided by 3,600 and multiply that by 95. That'll change to meters per second. So that's an conversion that you should be familiar with at this point. Converting from kilometers per hour to meters per second is 1,000 divided by 3,600. So I do that to both velocities so that I'm in so I can calculate the amount of energy in joules here. The time is in 7 seconds, so that's in the standard unit, so we're good there. So I can start plugging in what I have. So I've got the power due to friction, and we often think of power as things that are being generating energy or giving us energy, but we can also look at it in terms of how fast is it taking away the energy. And so we can look at the power that the friction has, how much energy is it taking away per second. So if I take the final kinetic energy minus the initial kinetic energy, 1/2 mv squared minus 1/2 mvo squared, and then divide that by the time that that energy loss occurs, I can get the power of friction, which is a negative number, which makes sense since it's taking away energy every second. When I calculated that, and then I get this negative 28,522 watts, that's telling me in every second, a little over 28,500 joules of energy is being lost due to friction, and at each second of time. So that's quite a bit. So we need to have an engine that's actually maintaining that. And this is where the conservation of energy comes into play. Well, if I want to maintain the same amount of energy as I did if it was a frictionless environment, and friction is taking away over 28,500 per second, then I need a car that will do the opposite of that and add that back in. So the friction and the car's powers need to be equal to each other. And so that we can say that the car's power needs to be around 2.9 times 10 to the 4th watts. And I used two significant figures because we had two significant figures on the time as well as on the speeds.